You already have Mega on your computer, don't you?
Yeah.
Yeah. That's fine.
It still
Control
does.
A, Control C. Yeah. You're gonna go into Genius, and you're gonna select.
This one? The orange one?
Yep.
And then
You're gonna select local.
So I did Control A.
Control C. You're copying the whole thing.
Under the local or under it?
You're copying the whole tree background file.
And then it'll probably open up like that, and you just copy them.
You're copying the whole tree background file. You'll go to Genius and you'll go up to File and say New and say Folder. New folder. I'm going to call my folder 3300 Fall 19. As you might see, I have a whole bunch of other folders. You won't have very many at all. So I created that folder. Now I'm going to select
That's pretty good
it.
size.
I'm going to select that folder. And all I'm going to do is say Control V or Command V, depending on whether you have a Mac or a PC. You're pasting those sequences into this file. It's going to ask you if you want to make a list or keep them separate. You want to keep them separate. So you should be somewhere vaguely looking like this. Why did I give you these sequences? Because making a phylogenetic tree requires a broader, more diverse data set than just the one sequence that you're going to bring in. So an attractive tree will have a little bit of diversity. I also have in this what's called an outgroup. An outgroup is something so different that it tells the computer programs to cluster things properly. My outgroup here is called Methanococcus volte. It's an archaea, and so its ribosomal gene is really, really, really different. For example, Aziz, remember back here? It's the great-great-grandma. It's the most different. So these guys are going to cluster together, and Methanococcus volte will be on the outside. It's an outgroup. How many folks are in this spot? Great. You, my dear, said keep seeing. Okay, if you're stuck, it's okay. It's okay. Just keep taking notes and stick with me. I'm going to go to my sequence that I got from Dr. Becca, which is, I can't choose any of y'all sequences because then I'd be doing it for you. So I'm gonna.
You can just blank it out and choose one. That way you don't know whose it is. Is that a hand?
Okay. So now I'm back in my 3300 Fall 19 folder, and I have 7 sequences. You'll see the little the number 7 right here to tell you how many are in there. Now you can paste that sequence that I gave you. You can paste it right in there. It's going to be called Clipboard Contents, and you can rename it My Soil Excellent.
Okay, I'm sorry, how did you just do that?
I copied from the sheet on the internet. I copied the sequence from the sheet on the internet. Your analysis and make a tree that would give you probably a B. I'm also going to show you how to make an A tree. So let me show you how to make a B tree, and then I'll show you how to make an A tree.
What's the difference?
A B tree is like crazy, crazy easy. You just select all of these sequences. You get an A on one, you get a B on one.
Oh.
You press align and multiple align. Use the defaults, just press OK. And now what it's doing, the computer program is seeing which positions in this gene it's allowed to compare in order to figure out who's related to whom. So let's say we have our 1500 base pairs, and then we have your little sequence. Does it match match here? Or does it match here? Or does it match here? That's what the computer program is figuring out right now. For this person, it matches right in the middle. So here's all our other 7 sequences. This dark stuff right here is the place that matches. And here's the soil isolate. It's a little smaller. We know that. We expected that. And it aligns right to the middle of these other sequences. That's how it's supposed to look. Now, I just press tree. That's all I do. There's a little button up here that says tree. I make sure the out group is the archaea. And then I press OK. Ta-da! That is the super easy B tree. That's why we use this program, because it is really
For
like,
outgroup.
click and paste. This is the B tree. This says the soil isolate is related to Pseudomonas. So it's probably a gram negative, right? Here, this makes sense. This is an alpha proteobacteria. This is a gamma proteobacteria, and so is this. So E. coli and Pseudomonas are medium related to each other. This guy's a little more unrelated. All of these guys are gram-positive, so they're supposed to be different. And then this is our archaea. So this tree tells us a story about evolution that's true. And we're like, whew, thank goodness. Now, this is a B tree. That's totally cool. If you want an A tree, I'll show you how to do it. I'm going to delete these guys so I don't get them mixed up with stuff. Now I'm going to take my soil isolate and I'm going to go to BLAST. This is basic local alignment search tool. BLAST. What it's doing is searching a database of truly like tens of or hundreds of billions of sequences. Like I've contributed myself about 500 sequences to these databases. There are mountains of sequences. Some of those are 16S sequences because people do this all the time to identify bacteria. So what we're going to do is check the databases to see who's related to my guy right here. So that's what we're doing when we say BLAST. And you can choose the database. And I'm going to choose the one that says 16S, right? I'm picking the database to search in. So the rest of this, 16S ribosome, because that's the gene we got back. So we're searching that database.
Where's the 16S? I don't see it.
It's in database.
Okay, thank you.
If you select your isolate, press BLAST, it will ask you which database you want to search. You say 16S. Now the only other thing that y'all will change is the number of hits down here. This is the list, like the number of organisms it's going to show me. I'm saying 500. Yours probably defaults to 100 or maybe 50. Go ahead and make it 500. Go ahead and make it 500. Because we're going to pick a whole range. We're going to pick 10 sequences out of this list to add to your tree. And so we want a whole range of different bacteria to go with. And then we just press search. And now that same program that you might have used on the internet with NCDI, this program talks to that one. And it's integrated, it's integrated into this. If you want to play around inside Genius, there are actually a whole bunch of different ways to access other programs. It's a really nice platform and it makes things super easy. So this is thinking about it because it's looking through a really big database. And it says, looks to me like this organism is very similar to Pseudomonas. Up here in the top, there's a category called pair. That means pairwise identity. That means how much it matches. So, we've got a whole list of things that are a little fuzzy, but they all say Pseudomonas something. And they're all pretty similar. But remember, so this might be counted as the same species because it's larger than 97. But remember, we've got the size issue. Also, as I was telling Jocelyn earlier, you can go look up what Pseudomonas guara strain whatever, what its biochem results are, and if it doesn't match yours, maybe you don't have that same organism, right? So you can use data from a bunch of different spots. Okay, what am I gonna do here? I'm gonna select the guys I want, and then drag and drop. I'm gonna select one that's 98. How about one that's 95? One that's 90, I'm at 89, I'm at 4.
You just pick whatever type you
I
want.
want you to pick all the way down to like 88. And let's see how many sequences that is. Oh, it's only 2 track. This.
Just put check marks. You want check marks? No, we don't. Not for all of them.
We want 10. So right now I have 7,
You wanna really.
8, 9, 10. Now I can just drag those 10, oh, I have 11. Oops, into my new folder. The way I know it transferred is because now this says 19 instead of 7. Now, they all have funky names here, right? So we're gonna change the names by just copying it from here and then pasting it here. That funky name is called an accession number, and if you get super into phylogenetics, yeah, you'll need to know them. But for right now, you can just copy these species names and have them replace that accession number. Once you've copied everything, I swear, it is this easy. Align, multiple align, go for it, use the defaults. And then when that's done, you'll press tree and you'll have something beautiful. Like truly beautiful.
Okay, was it selected in which folder? Did you tell me?
I put them in my original folder where tree background and my isolate are.
You hit Control V, Control.
I just drag and drop. Now, here it is, here's the A tree, except you would have the proper names for all of these.
Oh, good. That's a
Yep.
good tree.
Much better looking tree, right?
What do you mean the proper
It
name?
looks like a giant.
Instead of
fork.
accession numbers, you would change all of those names, I just got lazy. Because in R doesn't mean anything to anyone about evolution, so put the actual species name, genus and species. What's really nice about this, what's like extra nice, is look, these gram positives are now clustering all together. This is what's supposed to happen, and the way that that happened is we added enough data for it to branch properly. So now we get all these pretty gram negatives, some of which may be antibiotic producers that have been written about, and we get a nice figure for our paper. Done.
Bingo.
Yeah.